As mentioned in the previous video, one of the first things we want to do is try and establish how competitive a firm's market is. Whether they're competing against a lot or almost no firms, and then once that's established, we can then move on and start talking about how do firms compete, how do they make different choices based on the different competitive environment which they're operating within. So in this video and the next one, the goal is to talk about 3 different measures for determining how concentrated a market is, and so therefore how competitive the market is. Each one has its pros and cons, but we'll go through them one at a time and sort of note those as we go. So in general, what we want to be able to use this to do is ask questions like, how does competition vary across different markets? As I mentioned in the previous video, why is it, or, if you take the local power company and you take the coffee shop alongside the road, they behave differently, they operate differently, their size differently, pretty much everything about them is different. And so how does market concentration, how does the level of competition influence those choices, influence those decisions, and then how can we look at different markets and conclude that some of the outcomes of those markets are based on these differences in the competitive environment present. It's also useful for how does this change over time. So if you look at the syllabus, we've got topics in the syllabus like mergers and those sorts of things where we should expect the level of competition, the level of concentration to change over time. And then also, how does it vary across countries, and how do different countries, maybe policies, impact competition and concentration? So here's just a very basic example, just 2 firms, or 2 industries, sorry, not 2 firms, Industry A and Industry B. In Industry A, there are 4 firms. The largest has a 50% market share, the second has a 40% market share, the third and fourth both have 5% market shares. In Industry B, there's 4 firms, just like A, but in Industry B, all 4 firms have 25% of the market. So just general question, which one is more competitive? Obviously, that's a question that's up for debate. Most of you will have a gut feeling on this, and I know what most of your guts are going to be saying, but there's not necessarily a right or wrong answer here. It's an opinion. However, that being said, most are going to say that Industry B looks a lot more competitive than Industry A because you have 4 firms and they're all equal size. So competition-wise, none of them should have substantial advantages over the others. They're all about equal sized. In Industry A, 90% of the market is controlled by the top 2 firms, and then firms 3 and 4 are relatively small. So most of your guts are going to say that Industry B is more competitive, and it probably is, but at the end of the day, that's an opinion question, so let's see how our different measures line up with what our gut tells us. Okay, so here's our 3 different ways we're going to measure concentration, and just in case it's not clear yet, when we say concentration is something's very concentrated, that means that there's not many firms, there's not much competition. If something's not very concentrated, that means there's lots and lots of firms and it's highly competitive. Okay, so the 3 ways we're going to do this, and again, we'll take them one at a time and talk about the pros and cons as we get to them. Concentration curves, concentration ratios, and then the Herfindahl index. The plan is in this video to handle concentration curves and concentration ratios, and then come back in the next video, deal with the Herfindahl index, and then some sort of general issues that we got to think about, consider when looking at any of these different measures. Okay, so a concentration curve, by using the terminology curves, a concentration curve, it should bring up images that we're going to have some kind of graph, and that is correct. So what we're going to do for concentration curves is we're going to rank the firms according to their market shares from largest to smallest. Now, that previous table where in industry A, firm 1 had 50%, firm 2 had 40%, firms 3 and 4 had 5% each, that's already ranked for us. Okay, so that was already from largest to smallest. But if it wasn't, we would just order it that way. And then we're going to accumulate those market shares to create a table where, or a graph, where on the horizontal axis is firms 1, 2, 3, 4, 5, and you can keep going. And then on the vertical axis is going to be the concentration, or the cumulative concentration that those firms have. So you can see here across the horizontal axis, the firms 1, 2, 3, 4. Both of these markets have 4 firms, and then the cumulative market share on the vertical axis. The red line is market A, the blue line is market B, and you can see that all we're doing is we're just adding up the market shares moving from left to right. So in market A, the first firm had 50% of the market share, the second firm had 40%, so that means the top 2 firms have 90%. The third firm had 5%, so the top 3 firms have 95%, and we're just plotting those points out. In market B, each firm had 25%, so firm 1, 25%. Firms 1 and 2 control 50%. Firms 1, 2, and 3 control 75%. So we're simply adding up the market shares of the top firms as we move our way down from largest firm to smallest firm, and we're plotting them out. Okay, so what does this tell us? What can we get from this? So there's several properties that a concentration measure should satisfy. So the first property, if one concentration measure is larger than the other, or for concentration curves, if one curve lies entirely above the other. So it's not that they flip back and forth, it's not that they intersect all over the place, and we'll see one that intersects several times later. It represents a higher level of concentration or a less competitive market. So in the previous slide, because that red line for market A was always above the blue line for market B, we would say that market A is more concentrated and is less competitive than market B, and that's exactly what our gut told us. Our gut told us market B looks more competitive, market A looks less competitive. Okay, the second property that our concentration measure should satisfy is that if we take sales from a small firm and move it to a larger firm, it should show increased concentration. So basically, if we take a small firm and we make them even smaller, and we take a big firm and we make them even bigger, then we should see higher levels of concentration and less competition. So here's my example. Firm 1 gets 3% of firm 4 sales. So this becomes 2% and this becomes 53%. Okay, so if we then simply replot these, we're going to have 53%, and I'll do this on the next slide graphically, and then 93%, and then 98%, and then 100%. And if we plot those out, we get something that looks like this, where you can see that this is just a little bit higher, little bit higher, little bit higher. This point's the same because by the time we get to 4 firms, the 4 firms control 100% of the market. But if you remember property 1, we said if one lies above the other, that's the more concentrated market. So all that's happened here is the market's become even more concentrated. Basically, the gap between the concentration curve of market A and the concentration curve of market B, so the red and blue lines, the gap is getting bigger. The gap between those two is getting bigger because market A is getting even more concentrated. Okay, third property. Concentration measures should capture the increase in concentration generated by merger. So here's market B. What if firms 1 and 2 merge? Now, concentration measures are used extensively by the Department of Justice and a bunch of other government agencies in terms of evaluating mergers. When we do the merger module later in the term, we will come back to that and talk about how these concentration measures are actually used, but that's one big way these are used. So if firms 1 and 2 merge, so in this particular case, these two merge, we now have 3 firms, and that top firm has 50% of the market. So now one firm has that, and now we have 2 other firms that still have 25% of the market. So if we take that and we come up with our concentration curve, we're going to have, notice that here we've got the top firm in both markets now have 50%. This is assuming that second change where 3% of firm 4's market share in industry A, we undid that basically. So they both have 50%. Now for industry B, the top 2 firms now have 75, and the top 3 were already all the way to 100%. So here we get this crossing right here. So remember what we said before in terms of a property. If one concentration curve is always above another, that one's more concentrated. Here we get this crossing, so it's less clear in terms of which one is more concentrated, which one is less concentrated. If we have a curve where it's always above it, like we had in the previous examples, then we can be a little more definitive about this industry is more concentrated or less concentrated, meaning more or less competitive. Now, concentration curves are nice, they're helpful, they're nice visuals of what's going on, maybe over time or comparing a couple of industries. But you could imagine that if you wanted to look at a whole bunch of industries, it would become kind of tedious to pick apart what's going on within a graph, because there'd be all kinds of lines and they'd be crossing left and right, those sorts of things. So the 2 more common ways of measuring concentration and then competition are through concentration ratios or the Herfindahl index. So we'll handle concentration ratios now and then the Herfindahl index in the next video. So concentration ratios are still measured in terms of market share, sales, employees, some kind of size measure. When we get later into the class, we'll look at different ways or different measures that we can base concentration ratios on. But basically what we're going to do is we're going to create a ratio, and we're going to do this, and so you will see, and I'll have a link to a government website later in the next video showing different concentration ratios. We're going to take the top 4, 8, 20, 50, 100. The government does a whole variety of these, and look at how much of the market is controlled by those firms. So this mathematical equation is basically just saying, look, we're going to create a concentration ratio where we sum up the market share of the top so many firms. So it could be the top 4 firms, 8 firms, 20 firms, whatever. It's not all firms. And that'll be an important distinction when we talk about the Herfindahl index later. It's not all firms, and the reason we don't want to add up all firms is because if we add up all firms, we're going to get a concentration ratio of 100. Okay, so if we add up the market share of every firm out there, we get the total market. And so no matter what, if we add up the concentration ratio of every single firm, we're going to get 100, so that doesn't tell us anything. So we don't even bother adding up the concentration ratios of all firms, because it's meaningless. It's going to always give us 100, because that's going to be all the firms control 100% of the market. Instead, what we're going to do is we're going to add up the concentration or the market shares of some subset of firms. And we're always still ordering these by largest to smallest. So when we say the CR4, we're adding up the concentration ratio of the largest 4 firms, or CR8, the largest 8, CR20, the largest 20, so on and so forth. And we're just adding up the market share of those firms. This measure is bound between 0 and 100. 100 is going to be the max. That would be the entire market. And 0, it's unlikely, but you could, if they were small enough, I guess, if you had so many thousands of firms, you could be each firm with an infinitesimally small market share. You could be pretty darn close to 0. It'd be hard to be 0, but you could be pretty darn close to 0. Where rounding wise, you just maybe call it 0, but that's really going to be unusual. So if we try and apply this to the industries that we had before, okay, so here's the CR4 of the two industries. So for industry A, we're just going to add up the market share of the top 4 firms and get 100. For industry B, we're going to add up the market share of the next 4 firm or the top 4 firms and get 100. If we did a CR2, this would be 90 and this would be 50. If we did a CR3, this would be the top one would be 95, the bottom one would be 75. So we can do any numbers, 4, 8, 20, 50, 100. Those are the common ones. But this example actually points to one of the problems with the concentration ratio. These are the same. Okay. In our example, when we started this, I asked sort of the hypothetical, which industry do you think is more competitive? And I said, most of your guts are going to say industry B is more competitive. One of the downfalls of the concentration ratio is it may or may not show that difference. So if we do a CR4 here, because there's only 4 firms in each industry, we get that they're both equally competitive. Yet we don't have the sense that they're equally competitive, because in industry A, 90% is by 2 firms. In industry B, 50% is by 2 firms. So our gut was telling us that industry A is more concentrated, less competitive. Industry B is less concentrated, more competitive. But our measure is not really showing that. And that's one of the downsides of this. It's a very common measure that the government reports, and I'll, in the next video, show you where you can find it. But it's sort of one of the downsides of this, and why maybe the Herfindahl index that we'll talk about in the next video is slightly preferred to just straight concentration ratios.